Hi, this is Frank in another video, Frank Physics, and in this video we will be talking about momentum. Momentum is represented by a letter lowercase p. Let me start up with the definition of momentum itself. Let me just have an example with me where I have a body which is having a mass m and is traveling with a velocity v. So momentum for this particular body would be given by product of mass and velocity. So P is equal to mass times velocity. So I can write this in a very compact form as m times v. P is equal to mass into velocity. Let's have an example before I can delve more into momentum. Let me just assume that I have a ball which is of 100 grams. It is moving to my right with a velocity of 5 meters per second. Let's assume that this ball collides with a wall, and it bounces back in a direction to my left, and let's assume that the velocity with which it rebounds is 3 meters per second. So it is coming towards the wall, it rebounds from the wall, and while going it moves with the velocity 3 meters per second. Now I have two values, two sets of values, m and v, and this is another v, after colliding with the wall. Okay, so I'll just assume that before colliding with the ball, the momentum of the ball is pi. That's initial momentum. Like, let me just write that pi stands for initial momentum, and while it comes off from the wall, like it rebounds from the wall, I would just assume that pf to be the final momentum. I'm going to use this formula to calculate the initial momentum of the ball. So it says it should be 100 grams, and since we are dealing with the SI unit, I'll be converting this into kilograms. So 100 converting to kilograms would be 0.1 kilograms. So mass happens to be 0.1 kilogram multiplied by the velocity, which is 5 meter per second. Okay, so that gives me a value of the initial momentum at 0.5 kilogram meter per second. That happens to be the unit of momentum. Likewise, I can calculate the pf, that's the final momentum, using the values given over here. Of course, the mass of the ball will remain same, so pf would be equal to 0.1 kilogram converted from 100 grams multiplied by 3. Okay, I will draw your attention towards one fact which is very, very important when we are dealing with the momentum topic. We know that as per the formula, we are dealing with mass and velocity, and you remember that the velocity is not just a number, but it is also a direction. So I need to consider the velocity direction as well. As you can see that this 5 meter per second is towards my right, and this 3 meter per second is towards my left. Directions are exactly opposite. So I would have to consider, if I consider this to be my positive velocity, I have to consider this to be negative, or other way around it. So I'm going to be adding the negative sign here because the direction has changed. So final momentum would be equal to zero point 0.3 negative, and the units would be same. So that's my pi value, zero point 0.5, that's positive, and pf would be negative 0.3 kilogram meter per second. So that's an example of momentum. I'm going to explain the concept of momentum with another example. Right? I have a car which is of 1500 kg. Seems like quite a heavy car. It is moving towards a wall. I mean, on its way to collide with a wall. Let me say it's moving with 10 meter per second, and that's the wall. Okay, that's the wall, and after colliding with the wall it becomes crumpled. I know that the velocity will become like 0 meter per second because it comes to halt after colliding with the wall. So this is initial condition, and after colliding with the wall this is the final condition. So I got two momenta over here. One is initial momenta, and this is my final momentum. Let me just calculate the initial momentum first. Pi is, that's the initial momentum, is equal to mass of the car multiplied by the velocity, and that seems like 1500, another zero, and the unit is kilogram meter per second. That's my initial momentum of the car. It was sort of moving. And what will be the final momentum? It would be mass. Of course, it doesn't change. And the velocity is zero because it collides and remains there. So it seems like the momentum becomes zero finally. Okay, we dealt with two examples and we find out what is initial momentum and how to calculate momentum. Another thing that I want to introduce to you is everywhere in physics, whenever you see this sign, this means change. That's the notation delta. Okay, so if I write something like delta in front of p, I mean to say it's the change in momentum. So delta p is change in momentum. Alright, and always remember whenever we calculate something like change, it is always the final condition minus initial condition. It's an important factor. If you want to calculate the change in something, it should be always like final minus initial. So if you want to calculate the change in momentum would be equal to uh, the final momentum minus initial momentum. Just have an example of this car. Okay, let's calculate change in momentum of this particular car. Let's see. Okay, that is, I'm gonna just substitute those values up here. Okay, that's PF. PF I calculated to be 0, and PI is 15,000. So the value would be negative 15,000 kilograms meter per second. So, okay, the important thing over here is to understand the significance of negative sign. This negative sign tells me about the loss. The car has undergone a loss of momentum. That's why this negative sign appears. Negative sign means that the momentum has been lost by the car. Okay, we're gonna skip back to this previous question and let's see what will be the change in momentum for that ball which collided the wall. This is the condition. This is the question that I was referring to. So in this particular thing, delta p, that's change in momentum, is, as I told you, the formula pf minus pi. That is negative zero point 0.3 that it comes from, minus the initial momentum which is 0.5, and that is negative 0.8 kilogram meter per second. So change in momentum for this particular ball which is colliding with the wall is equal to negative 0.8 kilogram meter per second. So as you can see here again, it comes a negative sign. That means again this is referring to the loss of momentum by the ball here. I'll discuss one more example about how to calculate all this, and then we can wrap up the video. Okay, that's example 3. And I will again, I need to take the example of a ball again. So that's 50-gram ball which was moving with a velocity of 5 meter per second, and it was suddenly hit by a baseball. Okay, that is not quite artistic. It can actually serve my purpose. And after being hit, the ball travels to my left, speed or velocity 7 meter per second. So I need to calculate what is the change in momentum of the ball. Let me just consider this to be having pi and this to be pf. That's my initial condition before hitting the bat, and this is the final after being hit by the bat. Okay, so pi, that's the initial momentum, is 0.05 kilogram. Of course, 50 grams converted into kilograms, multiply by the velocity of the ball initially, that is 0.25 kilogram meter per second. Okay, that's the initial momentum. Let me just calculate the final momentum. Final momentum is equal to, oh right, I need to consider that the mass of the balls remains the same, and of course it does so, right? So 7 meter per second, that after multiplication it should give me 0.35, but I think I should add something to it. See that since the direction of velocity has changed, I need to put a negative sign there. So it has to be negative because the velocity has reversed. So now is the time to calculate the change in momentum, which is given by pf minus pi. That is equal to negative 0.35 minus 0.25, I think. Yeah, that's fine. And that gives me 0.60 kilogram meter per second. As you can see that we got another negative sign here. That means somehow the ball loses the momentum. Okay, and again, as I told you, I've been telling you that negative sign represents loss. So loss of the momentum results in. Okay, that was all about the change in momentum. Now I need to introduce to you something new, and that term is impulse, and it is represented by J. Plus, J is a vector quantity like momentum. J is nothing but the change in momentum. So I can write change in momentum is equal to impulse. So whether you call change in momentum or you call it impulse, they both mean the same thing. So that's the end of this video. Over here in this video, we talked about a few things. We talked about the definition of momentum, and we saw that how to calculate the momentum for a moving body, and then we figured out how to find out the change in momentum of a body, and finally we introduced a term called impulse, which happens to be another name of change in momentum. Okay, that's all for this video. Next video, we're going to continue the discussion on momentum and law of conservation of momentum.